Hello everyone. In previous class we discussed the basics of electric field lines or electric field intensity of electric field. Today we will start with electric field lines. So today we will discuss two topics, that is representation of electric field lines and properties of electric field lines. Okay, so first we will start with representation of electric field lines. So before that, what is electric field lines? As we have explained earlier, that is, electric field is a region or a space around which a test charge can experience some electrostatic force exerted by another charge. That means if we place a test charge over here, suppose it is plus Q, and one another charge is placed over here, that it is Q, and if this is the region up to which this charge plus Q charge can exert the force, in that case this charge will experience some force or it will move towards the source charge. Reason being, the source charge is far greater than this test charge. In that case, if both the charges are same, so this charge will experience a force in the direction outward, clear? But if this charge is negative, in that case this charge will experience a force like this, inward, clear? So what will happen in that case? This will move toward this charge along this path. This path is known as the electric field lines. Clear? So first we will write down the definition of electric field lines, then we will explain it. Electric field lines. Are imaginary path around which a unit positive test charge tends to move in the electric field of the source charge. Clear? Now we will see the representation at different conditions. So next is the representation of electric field lines. Next is the representation of electric field lines. First case, when Q, that is charge Q, is greater than 0. Q is greater than 0 means our charge is positive. Okay, so suppose here we have a positive charge plus Q. So how will you find Either either the electric field lines will move outward or inward. So what to do? Simply we'll place a unit positive test charge at any point. So if you place a unit positive test charge over here, you will observe the similar force will repel the similar charges will repel each other. Means this will be the direction of force, that is outward. Clear? If we place a positive charge over here, so we can draw clear? Means electric field lines always originate from positive charge. Clear? Next, case 2. Q is smaller than 0. That means in this case this charge minus Q. Okay, so how find the electric field lines in that? So what to do? Simply we'll again place a positive charge, unit positive charge over here. Okay, so if this is negative and this is positive, so we know that opposite charges attract each other. That means this unit positive charge will move towards the negative charge or source charge. So similarly we can draw clear? So we can say that all electric field lines will terminate at negative charge. It originates from positive charge and terminates at negative charge. We will discuss it in properties of electric field lines. Clear? Next is third case. That is for unlike charge. That means we will take one charge as positive and another as negative. And this is also known as a case of dipole. We will discuss in next video, that is what is dipole. Okay, so unlike charges. That means if we have a positive Q and a positive and negative charges, then what will happen? As we know that this, it starts from positive charge and terminates at negative charge. So this is the straight path. So our electric field lines may be straight or may be curved path. So if we place a positive charge over here, then what will be the direction? Like this. And this will be the direction of movement. Clear? In all cases, this should be inward. At negative charge, this should be inward, and at positive charge, this should be outward. Clear? So for online charges, this will be the representation of electric field lines. Fourth is for line charges. for like or similar charges. Here we have two different conditions, that is first case or case A, where magnitude of both the charges are equal, that means Q1 is equals to Q2. So in that case plus Q1 and plus Q2, either it will be positive or negative, both will be positive or negative. Clear? So in that case, okay, and again the direction will be outward because here both the charges are positive. Clear? And this point is known as P. Point P is known as neutral point. Neutral point. That means at this point the net electric field is 0. Clear? So that is known as neutral point. And point P will be at the center of these two charges. Center of these two charges. Next is case 2 or case B. If magnitude of Q1 is greater than magnitude of Q2, in that case here you can see this distance is greater than this distance because the magnitude of Q1 is more as compared to Q2. Hence the force applied by Q1 is greater than the force applied by Q2. Okay. Okay, again the direction will be outward because both the charges are positive. And here in this case we can say point P is at the center of the two charges. Okay, and here point P will shift towards the lower or smaller charge, towards smaller charge. Okay, so these are some representation of electric field lines. Next we will discuss the properties of electric field lines. Next is properties of electric field lines. So the first property is two electric field lines never intersect each other. Two electric field lines never intersect each other. Now the question is why? So suppose we have two electric field lines, line 1 and line 2, 1 and 2. Okay, and these are its forward direction. So if two electric field lines intersect each other at a point, suppose they are intersect at point P. Two electric field lines 1 and 2 suppose intersect at a point P, then what will happen? At this point P, now we have two different tangents. First this and second this, E1 and E2. Okay, but according to mathematics we can draw only one tangent at any point. So this is mathematically wrong. That's why two electric field lines never intersect each other at any point. Clear? Second point, electric field lines originates from positive charge and terminates at negative charge. Means suppose we have a positive charge plus Q over here. That means these are the direction of electric field lines. Means it will move radially outward. Direction will be radially outward. Okay, and if we have, and it will move to infinity. If nothing is there, no negative or positive charge is there, that means this field line will move up to infinity. And if a negative charge is placed over here, that means the direction will be radially inward. Clear? Radially inward. Okay, and if nothing is there, no other charges are present, then these lines will came from infinity. From infinity. Okay, but if a positive charge and a negative charge is there, that means suppose we have a positive charge over here and a negative charge over here. In that case, this will be the direction of electric field lines. It will originates from positive charge and terminates at negative charge, and it forms a continuous curve from positive to negative. Clear? Third is related to this one only. So third, electric field lines never form closed continuous curve. Okay, means closed continuous means if a line starts from here and after some time it will terminate over here. This is only possible if both the charges are present over here, but here both charges are separated at some distance. In that case, electric field lines will start from positive charge and terminates at negative charge. So it will never form a closed continuous curve. Clear? It will form a continuous curve, but it won't form any closed continuous curve. Closed means like this, and continuous curve means like this. Clear? Next, 4. Uniform and non-uniform. Uniform and non-uniform electric field lines. So if all the electric field lines are at a fixed distance, okay, in that case, this is known as uniform electric field lines. But if all electric field lines are distributed like this, means that they are not moving at a fixed distance, means the distance between them are different. In that case, this is known as non-uniform electric field lines. Okay. Property number 5. Magnitude of electric field lines is directly proportional to directly proportional to the density of electric field lines. That means if the amount of, suppose here we have a positive charge plus Q, here we have a negative charge minus Q. So at this point, the density of electric field lines is more as compared to this point. That means the strength of electric field lines is strong over here as compared to this point. Magnitude of electric field lines or strength, magnitude or strength is greater at this point as compared to this point, because at this point the density of electric field lines is less as compared to this point. Clear? Next. Next is electric field lines are always perpendicular to the surface of charged conductor. Suppose we have a charged conductor like this, okay, and suppose positive charge is distributed at the surface of this conductor, okay. So in that case, this will be the electric field lines, which is always perpendicular to the surface of the charged conductor. Clear? What about the inside one? Here, in this case, the total electric field inside the conductor is 0. Clear? So these are two topics that we have discussed. In next class, we will start the electric dipole. Thank you.